Hi everybody. I and my partner, we did a project this term on controlling USB to move a servo motor using LXRT, and this was for master's course thing that we done at school. So me and my partner, we're going to explain what our project was, and then we're going to show you a quick demo. So my partner, he's going to explain what LXRT is a bit and how we program the code to make this servo right here run. So
LXRT is a way to control or to prove out your code for RTIA, so real-time application tasks. And LXRT is an extension of RTIA, and what we've done is written a task in LXRT, so in user space, which controls a servo motor in real time. The advantage of that is that in user space, by running a task in user space, it alleviates the need to insert modules straight into the kernel, and if there's any mistakes in the code, that won't crash your system as otherwise would happen with erroneous code being inserted straight into the kernel. So what we have here is a connection between a USB from a computer going to a device called a bit whacker. And what this device does is it in essence gives you the ability to have a parallel port on the computer that does not have a native parallel port on it. So what's happening right now is that our code is generating a signal or a command that is being sent through the USB to the bit whacker, and the bit whacker then fires the pulse modulation signal through its pin and controls the motor. So if we can run the application right now.
So we are using we are using Linux kernel like to run this whole thing on Mac, as you can see. So yeah, let's test it out.
Okay, so what we've done is we already moved it. So what I'm doing right now is just basically changing the amount of bits or the time duration that will modulate the signal, and we'll make it and then run it, and you'll see that wasn't enough, so let's just change it to a little bit more.
So there you go. Just quick looking at the electrical diagram, if any of you want to do this at home, you can see the bit whacker, it needs a USB connection to a computer source to make sure you can program onto this bit whacker. Also to know, we have batteries over here, so we use 4.8 volts of 4 rechargeable batteries, and so we just plug them in series and we have 4.8 volts, which won't burn out our servo motor here. And the servo is connected to ground on the bit whacker, as well as the signal is connected to pin 4, as my partner has mentioned.